Okay, so we are live. Hello, everyone, and welcome to the Cloud Native Sustainability Week Day 2. And my name is Saiyam Pathak, and I'm a CNCF ambassador working as a field CTO at Civo. And I'm joined by my very good friend, Divya.
Hi everyone, I'm Divya and I am also a CNCF ambassador. No surprises there. We are doing this as part of Cloud Native Sustainability Week, and I work as senior technical evangelist at SUSE. And over and above all the ambassadorial duties, if I get the adjective right, I am also one of the maintainers for documentation on the Kubernetes project. um, but yes, why are we here today, and what are we going to talk about?
Yep. So again, setting the context, Cloud Native Sustainability Week is the week organized by the Tag Environment Sustainability under CNCF, and us as part of that, we are driving this live stream series so that we can learn something new, something interesting each day. And definitely, environment sustainability is related to cloud native. It's the landscape. And how we can learn more from it, implement some of the stuff that we learn. That's what it's all about. Yesterday, we had stream with Hendrik, and we did learn about Kepler, a project, a CNCF project, and we did learn about Cube Green, and we did learn about how to use them in conjunction to actually create a useful workflow. And today, I just saw recently, like a few hours ago, Divya wrote a blog
Yep.
post on the same. So, Divya, it would be great if you can share that as well with the audience, so
Yeah.
that you can understand what was there, like the summary kind of. And yeah, it went well. So today we are like diving into another dimension on the hardware side, and we'll try to understand the data center stuff, how the stuff works there, how the data center folks are thinking with respect to sustainability, what efforts they are doing with respect to sustainability. So I think today will be again a very thoughtful, knowledgeable session. And I would like to introduce Mark, who is the CEO of Deep Green. Thank you so much, Mark, for joining in and giving us your time and explaining about sustainability. Can you give a quick introduction to the audience?
Sure. Hello, everyone. My name is Mark Bjornsgaard. I'm the chief exec of Deep Green. We are building an edge data center network. The most important thing for us is recapturing the heat. So I've got some slides that I'm going to go through, which hopefully shouldn't take more than sort of 10, 15 minutes. But we're building different types of data centers. So conventional data centers, as some people may or may not know, are often are very large buildings in the middle of nowhere, and with thousands and thousands of computers in them. We're doing kind of the opposite. So we're building we're breaking those data centers up, and we're taking the data centers to where heat is required. And so we'll talk a bit about how that is a sustainable and green solution. But really, what we're trying to do is figure out how data centers can be net contributors to society, not be as they are now, which are kind of a bit of a problem in terms of the climate and in environment in more generally.
Amazing. I think that would be really awesome. I mean, I love the first slide itself, waste heat from the data centers, how to use that, because the data centers produce a lot of heat. And I mean that's something, you know so innovative to hear itself, like we can actually use the data center heat to do something else, and use it, and put it to use in some other direction. So yeah,
Yeah,
that was the motive behind doing this series of stream. And so excited to have Mark with us today to dive into some of the stuff, some of the learnings, some of the stuff that they are doing, and his opinions on what sustainability means in the world of data centers.
great. Well, look, yeah. So I'll the slides I've got shape what we're doing at a very, very high level. But so it's a very big, broad brush. It looks into the future, and we describe 3 phases, 3 kind of ages of how we'll think about waste heat and data centers in the future. So yeah, should I just go ahead and we'll talk through them? But I guess if anyone wants to ask questions or puts hands up, whatever, we can stop. Be very happy to kind of interrupt and stop and chat through them. Is that so? Let me start then. Let me get onto those slides. So we think of heat from data centers, and we'll talk a lot about the sort of different aspects of sustainability as I go along. But we think of heat from data centers in 3 phases. At the moment, in what is, as we know, which is a climate crisis, we're in this age of what we think of as adaption. We are, at the moment, we are still building data centers as we've always built them, but we think in the future that's going to change. But we're in this slightly awkward phase where we're all trying to wrap our heads around how we can use this heat. Because as you say, the logic of it seems kind of pretty simple, right? My laptop gets hot, my local swimming pool or distillery or flats, they need that heat. So we surely must be able to use this heat. But at the moment, these principles and these ideas we're just sort of starting to get our heads around them. We know that the data center industry consumes a huge amount of electricity. So on different statistics that you might hear, anywhere up to 3% of the world's electricity supply is being consumed by data centers. The problem is, and that for data centers is a problem, because they are starting to be seen to be this bad thing, that they are a sustainability and a climate kind of crisis target. So it's, you know, more greenhouse gases than the airline industry. But the really challenging thing is that that's set to grow. So the problem that we've got, this kind of existential problem that we have with data centers, is actually slightly more nuanced than we're kind of currently talking about. I think there's been a lot of talk. You may have seen a Panorama program in the UK about how data centers are kind of taking down local grids and not allowing EVs to be charged and all that good stuff. So we think data centers themselves are really problematic. If we were designing the data center industry now from a sustainability point of view, we would not design these massive barns in the middle of nowhere where pretty much all the electricity that goes into the computers comes out as heat and then just gets ejected into the atmosphere. But the computers themselves, those computers themselves are actually, we think, a really important sustainability asset. Probably one of the unsung heroes, we think, of the sustainability world. And the reason is that computers are brilliant electric heaters. 97% of the electricity that goes into a computer comes out as heat. And that is, as we said right at the top, that's incredible, because if we could possibly harness that heat, that could be a really big solve for the climate community. And that's what Microsoft, so in 2011, Microsoft coined this phrase, data furnaces. And they said that the first line in that white paper is, we argue that servers can be sent to homes and office buildings and used as a primary heat source. So that's really what we're doing at Deep Green. We're building data centers, we're building data centers where the heat is required. So our view of the world is that we need to stop building data centers in the middle of nowhere, and we need to start building them where as we say, where the heat is required. And that's exactly what we've done. So we have built a supercomputer in a swimming pool in the southwest of the UK, in Exmouth. And what we wanted to do by doing that is show how simple and easy it was to do this now. Because I think a lot of people, when they talk about heat reuse or they talk about sustainability in data centers, I think a lot of people, there are a lot of myths, there are a lot of misconceptions. And what we wanted to do is show that it was actually really simple to do. So without going into too much detail, we take the computers, we immerse them fully in an inert mineral oil. So it's a very odd thing to see because it looks like the computer is in water, but we literally put the whole computer in mineral oil. That mineral oil gets hot. So when the computers get hot, unlike a normal data center that blows cold air across them and then just tries to get rid of that heat, instead of doing that, the oil in this immersion tub, it gets hot, a convection current starts, and that oil starts to flow around a closed loop into what's called a heat exchanger. And from that heat exchanger, we then heat the cold water of the swimming pool. So the cold water of the swimming pool is on a separate loop. It comes very, very close contact with the oil, doesn't actually touch it, but comes very close to it. And all the heat in the oil goes from the oil into the pool. So super, super simple system. There's nothing difficult about it. We've actually built the entire data center in 3 days. Super, very, very easy. And that's one of the key principles here in terms of the kind of sustainability angle, that this is not technology. We're not doing anything unique or different in terms of the technology itself. It's all there to be repurposed. And there's a bunch of really good reasons why, from a sustainability point of view, this is a good idea. There's already enough power in the ground to do this. So when we landed in Exmouth, we didn't have to upgrade the power grid. So unlike when you're building a massive data center, often it's years and years before you can get enough power to power that data center. And then when you've done that, you actually deprive the local area of electricity to do other things, for heat pumps. So there's already enough power in the ground to do this. When we land, we accelerate the adoption of heat pumps. So we actually we can make heat pumps much more efficient, which means that as a pool operator or as somebody in industry who's thinking about adopting heat pumps, we can actually improve the economics. We can actually make it better to install a heat pump. And of course, by doing this, we are helping that community asset. So I think a lot of time in the sustainability community, we talk a lot about carbon, understandably, because carbon in the atmosphere is one of the biggest problems. But there's actually a bunch of other stuff that's really important in the E, the S, and the G. That social bit is that we are supporting, a key community assets here and helping swimming pools to stay open. We've already lost 300 swimming pools in the UK. We've got 1,500 left, roughly, and 700 of those are at risk. So in this age of adaptation, where we're all kind of trying to get our heads around how to reuse heat, whether this is a good idea, we're all kind of at different levels, and it's not yet normalized. But very soon, particularly because legislation is now coming in. So Germany have just come out with legislation a couple of weeks ago that says you're not allowed to build a data center unless you harvest the heat, unless you reuse the heat. Very soon, we're going to move into what we call this age of adoption. And this is where it gets really interesting, because we've got a problem with data centers now. They're 3% of the electricity supply of the country is taken by data centers. But to make all the good stuff that the robots can do for us, which is drive cars and all the great stuff we know AI is going to do for us, we need 10 times the amount of data centers we've currently got. And the question then becomes, how are we ever going to do that? There's just not enough electrons to go around. So the idea that the data center industry could potentially need 20% of the UK's electricity supply in 10 years' time, when every other industry is trying to electrify and decarbonize, this seems like super unlikely. So, but through the first stage, where we're all kind of trying to wrap our heads around heat reuse, suddenly we start to see that we can actually effectively use the same electrons twice. So high performance compute and data centers become this catalyst to enable the decarbonization of all of our heating systems. And this is to say, the next phase of this gets really exciting. So there's a brilliant map called the European Waste Heat Map, which is a kind of collaborative open source effort, and you can already see where heat is being reused across Europe. And this is an enormous opportunity. this is not a few kind of public swimming pools. We think this will be a huge sea change in our economies, and particularly for the data center industry. So what we say is that this explosion in demand for data centers, which is coming, it actually can't come fast enough, because once it's here, we can potentially heat all of the homes and offices in Europe for free. So this, and a sort of, that's kind of an interesting, it's kind of an interesting thing to try and get our heads around, right? Imagine a world where all of the homes and all of the offices and all of the physical infrastructure in our society is actually heated for free. That's kind of pretty amazing, and it's not actually us saying it. So Danfoss came out with a report at the beginning of the year saying pretty much exactly the same thing. They were talking about all of the waste heat in Europe, but as the data center industry grows, the data industry will start to be almost as much of that heat. And Danfoss has said that there is enough energy being wasted in Europe to heat all of our homes and offices for free. And then if we kind of get our heads around this second phase, then this becomes really super interesting, right? So we can build out this capacity very, very fast. It's not space lasers. It's not something that we have to, it's not small scale nuclear where we have to wait 10 years for the ability to be able to build it. And then even then we have to worry about all the downsides of this. We can build this capacity out really fast. We can, one of the biggest constraints in the sustainability world and in the climate change world from an energy and an electricity point of view is the issues with our grid. And one of the brilliant things about thinking about the data center industry in this way is that we can start to take data centers, what's called off-grid. We can start to run them, nearly 50% of them, we can start to run them on solar. Because our data centers are really small and the amount of available space we have around our data centers is actually quite big, we can land enough solar near to our data centers to be able to run them almost completely, while the sun is shining at least, off grid. And that puts a lot less pressure on the grid, which allows the grid then to supply electricity to other people in the economy. And then finally, we were talking about this actually just before we started, perhaps the greenest thing we can do is keep internet traffic and network traffic local. So data centers in the world are 3% of the electricity supply, but actually transmission networks and 5G networks, another 3% of electricity. And if we can keep traffic local, 70% of the traffic on the web is video. If we can keep that video traffic local, it's actually an incredibly green thing to do. It means that we use way less electricity in networks. So in this age of adoption, as we all get our heads around this, and this starts to become the norm for us, as it doesn't start to feel weird about reusing these electrons twice, we then see that actually this just makes data centers better. It actually makes them more profitable because we don't have any cooling costs and we can deploy wherever we like. And so by 2040, you can actually see a scenario where data centers and high performance compute could be responsible for decarbonizing a lot of the economy, like a significant amount of the economy. So all of that big chunk of electricity and heat production actually could be underpinned by heat coming from edge data centers. So finally, I'm only probably speak for another 5 minutes. I hope everyone's still with me. Finally, we come to this age of amalgamation. And this is where in 10 years' time, we've all got our heads around this. This has become the norm. And then things start to get super interesting, right? So demand won't stop at 10 times. So in the next 10 years, we need 10 times the amount of data centers. But of course, exponential curves do what exponential curves do, right? They grow. So in 20 years' time, we'll need 30 times the amount of data centers we currently need. And then the question becomes, wow, where do we put those? Where do we put those data centers? And the really exciting thing is that 30% of all industrial processes need this, can use data centers. So it's not just home heating, it's not just heating our homes and offices, it's 30% of all industry can host a data center. So whether you're a laundry, whether you're a distillery, whether you're food production, you're washing plastics, industrial drying, a huge swathes of our economy can actually use data centers. So if we go right back to that first principle where we're anchored, which is we stop building data centers in the middle of nowhere and just venting all that heat, bring them to where all of these industrial processes can use this heat, we can start to imagine a completely different world, a completely different type of community and society. Perhaps most importantly of all, we think there's going to be a massive expansion in urban farming underpinned by data centers. So that middle picture is a really interesting scale up now from the US, where they're growing shrimps in containers. And those shrimps happen to need hot water, warm water at about 30 degrees, about the same temperature as a public swimming pool. But a bunch of other types of urban farming can also use heat to grow food for us to eat. And if we start doing that, then we start to reduce the air miles in all the food that we eat and consume. And the whole idea of our local economies might start to change. We might start to see, instead of our town centres looking a bit like that, a bit windswept, hollowed out, really not having a purpose. Why is a town centre there? To what use do we put our town centres? We can start to think of our town centres in a completely different way. So all of this free energy, this free heat, we start to think of them as in a completely different way. So imagine somewhere between the Hanging Gardens of Babylon and the Eden Project. I don't know if anyone's been to the Eden Project, but these enclosed spaces where we're coming together. We've got leisure facilities, we've got urban agriculture, we've got local industries. So we stop centralizing, we stop putting all our industries in the middle of nowhere where they're just using more and more electrons on their own. We start to repatriate them back to our towns, in the middle of our towns and cities. And then in 20, 30 years time, you can start to see how data center heat could actually be responsible for decarbonizing more than 50% of the economy. Because once heat production, once different types of industry start to use the heat substrate, this free heat substrate that we can make available, suddenly we can start to see how, instead of data centers at the moment now being kind of pariahs and people really not wanting them around, then actually they become this really important catalyst for the energy transition. So that's us. That's the meta of what we're doing. It's a lot to take in, and I'm always sort of keen to kind of unpack different aspects of it. So I maybe stop there and kind of see where everyone is, and see if there are any questions or whether there are specific areas we want to kind of dive into.
Yeah, I think that was just mind blowing. First of all, let me tell you that it was amazing to learn something very interesting today. So the thing is, the innovation just doesn't happen in a day, and we cannot continue living the same way at the same pace with the stuff keep growing. Like you said, the demand for running servers are increasing because the number of applications are increasing. And for example, the OpenAI stuff, people are building massive crazy application every day. Like you sleep and tomorrow there is a new application. Like it's happening just like that. People need more GPUs. There are manufacturer delays in getting those GPUs. So I mean, there is so much things happening, and we just cannot continue living at the same way that we were used to when we started building the data centers. And rightly pointed by you, like thinking of different ways, like you mentioned, the 30% areas of real world scenarios, the food production, swimming pools, the offices, home, all the areas where people can actually get the benefit from the heat that is being produced by the data centers is so innovative. And can be used at like many different places, and you have already started it at a few places where it is
Yeah.
working foolproof and it is doing its job well, and it's not rocket science, like it's not that hard. um,
No.
as you
No.
imagine, it is doable. So I think the key takeaway is the first one was like 97% of the electricity goes out as heat. So I think that's very valuable
Yeah.
information, because that opens up a lot of opportunities, that what can we do with this heat? Do we let it go just like that, or we use it, reuse it for n number of use cases, which actually helps the real world, our day-to-day life
Yeah.
scenarios.
Yeah.
So I
And
think
I think,
that was really
yeah,
eye-opening.
I think it's I think there's that saying that the future's here, it's just not evenly distributed, right? And I think once you I think we perhaps frame heat reuse as this kind of rather esoteric kind of special thing, and it's true to say it is. It's not normal yet, but Helsinki, Stockholm, Oslo, Belfast, they're already plugged into district heating systems. And actually, if you go to the Nordics, they're already drying wood pellets with data center heat, and they're already fish farming with data centers. So this technology is there, it's just in really small pockets. And I think what the climate kind of what the climate lobby and what we need to do is kind of normalize this. So that's why kind of I think the age is like trying to frame it in these kind of phases helps people kind of get their heads around it. You know, it helps people sort of frame it as when and how it's going to land. But as you say, yeah, it's here already. It's just about doing more of it. And I think often the data center industry, to some degree, feels a little bit picked on, because if you look at waste heat across Europe, it's true to say that the data center industry is not the only industry wasting heat, right? You know, there are loads and loads of industries, you know, whether you run a blast furnace or you're a water treatment plant, there are plenty of people who are perhaps not making as good a use of waste heat as they might do. But the data center industry, what's unique, almost unique about the data center industry, is that heat is what we call structured. It's actually quite easy to capture in a way that if heat is coming out of your blast furnace, it's kind of hard to kind of, you know, kind of hard to heat anything from it. So yeah, I think the data industry has got, and I think that's how we really want to frame it, is it's got this, the data industry could be the heroes of the climate crisis, genuinely. Do you know what I mean? Like instead of being these pariahs where people are thinking, oh my God, I don't want a data center anywhere near my community. Actually, it should be the opposite. It should be, I really want a data center because it's going to heat my local swimming pool, or it's going to keep my local laundry open, or yeah. So I think it's about reframing it, the argument sometimes.
Yeah, absolutely. And want to point one more thing, that I'm super proud that Civo is in a very deeper partnership with Deep Green. So their servers, the Deep Green servers, are actually being powered by Civo. So anything that you run in the Deep Green region in the UK on Civo is 100% renewable energy and powering heat.
Yeah.
So I think I'm so happy that I'm talking to
It's
you,
so
learning
cool, isn't it?
sustainability and
Yeah,
thinking
yeah.
about
But it's
of the
real. It's
partnership. I mean,
actually real. Yeah, yeah,
it's real. So you
yeah,
can do that. So you can
yeah,
run your workload and it's powering the
yeah.
heat in.
I
I
know.
mean, that's so cool.
And this is where we 7 years ago we dreamed of being. So because it's really unfair to ask. Sometimes it's really unfair to ask people who really, you know, to who this is not their day jobs, to kind of get their heads around this stuff. But what's brilliant about what we've done with Civo is that you literally just click a button, right, and you decarbonize your compute. And that I think is really, that is exactly where we need to be. We need to make, it's so simple and so easy to make a good climate choice that it's just a no-brainer, right? Like, why wouldn't you? You know, why wouldn't you? It's like, if it's literally just to click a button and then all of your compute is decarbonized and it's doing some social good. It's so cool. It's very cool. Yeah. Yeah.
Yep, amazing. Like now I understand it even more. Obviously, I know the tech side of it on the CEO side, but
Yeah.
knowing about the stuff like the
There we
deep
go.
green stuff is also good. Yeah, amazing,
Yeah.
and
Yeah.
also great stuff on the vision. So the vision doesn't end here. So you rightly mentioned some of the areas that you think where the industry will be going, where the newer and newer data centers that the demand is going, and this thing, if done in the right way for the different set of causes, we can actually use it in favor of the environment rather than thinking of it as, it is causing bad impact on the environment. So I think that's
Yeah.
really cool to have a that sort of vision as well.
Well, I think, yeah, and what's really interesting about what we're doing is almost, it's not by default, but it's certainly something we don't talk about as a first thing is if you do this by almost just by happy accident, you build an edge network. So when we talk about all of the good stuff that we think the robots might do for us, which is whether that's driving cars or the metaverse or any of those kind of really low latency applications where we need compute really close to where we live and work. So smart retail, we need cameras. We need hundreds of cameras in each retail store so you'll just be able to walk in and pick something up. All of those use cases. By going heat first and saying, actually, let's not talk about edge because it's a bit chicken and egg. Do you know what I mean? Like we need the use cases to then build the edge network. Actually, if you go heat first and you say, I'm just going to help that swimming pool or that district heating system or that distillery, then almost just by happy chance, you happen to have, okay, hang on, I'm at Birmingham now. We've now got 50 data centers across Birmingham. Okay, hang on, we've got an edge network now. Now we can do all the good stuff. So there's a kind of there's a happy benefit on the compute side as well, I think. Yeah.
Yeah, definitely. I think the 5G, the telecom industry that needs many edge locations. I think that that fits really well for this particular use case. If you already have edge locations, you're already powering compute. It opens up doors for many other use cases that actually need the compute closer to you. Yeah, that's fantastic. There's one query from Andreas. Do you think certificates for sustainable hosting would make any difference, like certificates for organic ingredients?
It's interesting. I'm not quite sure what Andreas means by certificates, but I think certainly if we think of heat reuse in terms of regulation and the kind of carrot and stick, how would they make any difference? I think certainly. So on the one hand, you've got certificates in terms of kind of regulation, EU regulation, which is saying you've got to reuse your heat. So I think there's that sort of there's that kind of regulatory framework. And then perhaps what Andreas is referring to as certificates may be carbon taxation, and that's certainly coming. So as of May this year, under European legislation, if you're running a data center over 100 kilowatts, you've got to report what you're doing, and that is almost certainly a precursor to taxation. So being able to say, look, if you're not doing the right thing by the environment, you're going to have to pay more tax. So I think as a principle, yes, I think the industry being regulated and this coming to the kind of forefront of operators can only be a good thing. It will only make people think about this more. Yeah.
Awesome.
I can see another.
Yeah.
I have a
Sorry.
question. If I'm so sorry if I interrupted you,
No,
but I had a question, burning one at that.
please.
We did not talk about some of the challenges that you could potentially encounter. Like, I mean, obviously, I know that since you're in this industry, you're probably well versed with most of them. So, could you touch upon some of the challenges with all of
Yeah.
with bringing this into actual fruition?
Yeah, I think so. Sort of in order of sort of complexity, I think technically it's really rather simple, right? It's pretty. There's a really great statistic. There's already enough. There's more fiber. There's more fiber in the ground in the UK than there is in the US, in the whole of the US. So in terms of being able to build out data centers in less conventional places. technically immersing compute, the heat exchangers, all the hardware engineering around this is really actually quite straightforward. And as I say, we've been doing it for 7 years now. We kind of came out of stealth only 6 months ago. But so from the technical point of view, it's really pretty straightforward. I think the challenge is we're back to mindset. Really, the challenge is people understanding that this way of working is the kind of going to be the future, because a lot of people, I think, naturally are kind of you're building a data center in a district. Well, district heating systems are we've got some precedent for that happens in the Nordics, but I think as you get smaller and smaller and you get further out into the community, I think one of the biggest challenges is just getting people comfortable with the idea that this compute is it's all tier 3 rated, it's all the same security as a normal data center, but it's somewhere different. So I think a lot of the challenge of this is really in people's minds, and I think that's just something that, like anything that's new, you just have to very gently just keep persuading, and we don't see this happening overnight. We think this is going to be as we said, the ages, right? they're not quick sprints. We didn't call them the 3 sprints of data center. These are ages. These are going to take ages.
Yeah.
But what I can say is that the world is changing a hell of a lot faster than we thought it was. I mean, I think we all have some sense of kind of vague existential. I mean, like, why are we in a t-shirt? It's like in mid-October, right? Like, I think we can all sort of feel that the climate crisis is starting to bite. And I think that, in a good, bad way, is kind of helping, because people are, I think the debate of whether we have to do anything about this is kind of, most people are like, yeah, okay, I need to, at whatever level I can, I need to take some sort of responsibility for this. And we're sort of back to that. It's so easy to to click the button in Civo and say, I want to use it. Like, why wouldn't you? So it's not without its challenges, but I think they're becoming easier.
All right. But touching upon like the power management side of things, where you said that, currently, although the data centers are connected to the same grid as like the rest of it, and we plan to sort of like have this power residential, and use it closer to
Yes.
the audience, and use it for varied purposes. Like, for example, you said in Stockholm they are using it for producing wooden pellets and farm fishing.
Yes.
I would envision like problems around power management when that actually does end up happening on a larger scale,
Yes.
because you connected to the same source. Like, I am an electronics student, and visualizing that kind of thing is a little it's like, it's at a large scale. It will cause a lot of not a lot of there will be a lot of designing challenges and management
100%.
challenges
Yeah.
around the power distribution, and you'd probably need to sort of introduce close monitoring and stuff like
We
that
have,
in
yeah.
response to this thing, is what I'd assume.
So,
But
yeah.
at smaller scale, yeah, sorry.
No. Sorry. There's you're absolutely right. I mean, like last summer, we saw instances where data centers were taking whole sections of the grid offline. Right. West London, where the power just goes out because the data center's on. So that's why it's a kind of second order sort of what we're doing, but that's why running data centers off grid, we think, is super important. Because actually, when your primary source of power is your own solar and your own battery, you're not reliant on the grid. And so whilst you can we build a data center and it's got backup biogenerators and it's got batteries. So if you lose power, the UPS
can switch
kicks
over,
in, it switches over. Actually, what we think the really interesting thing about building in this way is that you can actually really kind of get yourself away from the grid at peak times. So if you can imagine, it starts to get really geeky, but basically the average size of a swimming pool car park is 2 to 5 acres. And And to run one of our data centers, you only need about 1.5 acres of solar panels. And the trouble is, if you've got a 100 megawatt data center, you need 220 acres of solar panels to run a 100 megawatt data center completely off solar. Now you're never going to do that. You've got a 100 megawatt
obviously
data
not.
center. That's like half of London, right? So
Yeah, sure.
what's really interesting is when you break the data center up and take these little bits, the relationship, the relative size of the data center compared to the size of the amount of space you've got for solar, it goes like that. And that's what actually, again, can make us so much more resilient. So you don't have that threat, that worry of power, because as you say, as we know, in the energy transition, things are going to get bumpy, right? We probably haven't enough storage on the grid. You know, the wind doesn't blow all the time. We know that actually in the next 5 to 10 years, power outages are likely to actually get worse before they get better. So I think anything that takes heavy load off the grid at peak times, and then the really good thing about doing this is then, of course, when the sun's not shining, when the grid's not under pressure, if the wind's blowing at the middle of night, then our batteries charge up, and that's when you actually get paid to take electricity off the grid. So you sort of have the best of both worlds. You're not stressing the grid when it's under stress, and you're helping suck up all this kind of stranded power. There's 1.3 terawatts of power that we waste from our wind every year in the UK because we just can't use it. We just turn the turbines off. So yeah, I think power is it gets super kind of geeky, but it's really, really important actually. And I think that's, you know, again, the kind of climate crisis and the sustainability. When we talk about sustainability, sadly, these things do get quite techie quite quickly, right? They're kind of second order problems.
Yeah.
We do really need to kind of tease these things out. But yeah, we're super focused on solar and batteries. We have another, prior to running Deep Green, I was running a venture capital firm, and we've invested in a heat battery business. And these are massive thermal stores which store electricity as heat in perfect vacuums, just molten rock and aluminium. But again, same thing. Lots of on-site solar, store the power in the battery behind the grid, so you don't stress the grid, and then you suck up the electrons from wind when there are plenty of them. So yeah, really important facet.
And one last question that I have personally, because I've visited data centers, so I was wondering if there are like different security standards that y'all have to adhere to when it comes to this specific area of can I call it a data furnace, because you said it in like one of the
No,
steps.
So I mean, already 70% of our data centers are actually what we are on-prem, right? Like 70% of our data centers aren't actually in data centers as we understand them. They're actually in kind of tier 1 and tier 2, kind of not very resilient sort of areas in an office. So
I get it. Yeah.
So but we're certainly taking that super seriously. So yeah, you absolutely have to take, and there are certain protocols that if you don't build your data center to that standard, you just don't get the certification. So you start to have to have gas axes, which are these kind of massive power tools. You've got to build walls that are metal, so you can't sort of you can't kind of get in with. So all of that you have to be super kind of buttoned down on. But the reality is most data center security is software related. You know, the number of times that data centers are compromised in terms of people physically breaking in and stealing data. I mean, it's not to say you mustn't absolutely make sure that it's not sorted, but the reality is you've got to do both. You've got to have the kind of security and the cybersecurity locked down, and then lockdown on the hardware side as well. But interestingly, I think again, edge and kind of telecoms. Obviously, telecoms kit has been at the edge, in MAST for 30 years. So I think interesting. I think people are kind of, I think the wider industry is getting a lot less worried about that. That's part of that mindset change where people are like, yeah, you know, containerized solutions, which are part of what we offer, they're kind of reasonably well established now. So people are less, but it's certainly a consideration.
Sure. Thank you. Thank you. That cleared up a lot of stuff because I've visited data centers as part of my previous job, and I was like, are there different security controls for,
Yeah.
this?
3 levels of security, swipe card
Yeah, yeah,
access. We
yeah,
have weight, so if you don't weigh the same as you weigh when you walked in as you came out,
yeah,
and so there you go.
yeah. True. Yeah.
It's there's certainly a pretty big science around it.
Yep.
I'm trying to look through if there are
Awesome.
any other questions. Yeah, there was a question around water, which I think is super interesting actually. It's water. I think from a sustainability point of view, water is a whole nother kind of category of. I think we were talking about this morning. 10 queries on ChatGPT is like a liter of water, and that water has its own environmental cost. And any one hyperscale data center can take something like 80 million liters of water a year, and all they're doing is just evaporating the heat off with that water. It's not like that water's goes and comes back. That just disappears again into the atmosphere with the heat. It's kind of nuts, right? yeah.
I mean,
That's statistics like that.
yeah, that's really interesting. So I think, wrapping stuff up, I think the very interesting session. Thank you for being there, Mark. We learned a lot. I think the audience would really like this angle of sustainability of the data centers. It's not the data centers, like the innovation is actually happening. Like it's not now on the theoretical grounds. It's in production. It's there. It's actually there because when you log into Civo, you can see a deep green region. It is there. So you can actually launch an instance, and all the stuff that has been there, you will be able to see it. So I think all those areas are very powerful. We heard the vision and the areas that it can expand to because of the demand of the data center increase, because of the number of applications that are increasing. People want to deploy, want to use the GPUs and all those things. So I think this will be super valuable for anyone who is building the data centers and trying to understand the sustainability angles, because we, like you said, we all are experiencing some sort of the other, the weather changes, the environmental stuff which is happening to us all around the globe. And that's what has kicked the tires of people thinking in all direction, and that is why we are here for this week. So this sustainability week, we are trying to understand different hardware layers, software layers, trying to understand different new softwares which have been there, research papers, the work that you have put in, so that all the audience can understand that it's not that you cannot do, like it's not something you have to be on the ground to do something. You can actually do a lot of things with the software, with the hardware that you are using, and create an impact when done together. So when you say millions of people doing it together, there is a bigger impact that you can see on the environment. Just before we close, there is one more question from Harsh, that assuming there is no carbon taxation, are data center cloud providers economically incentivized to take the greener approach?
Yeah, it's a really interesting question. It's a really interesting question. We talk about this a lot. I think I can't remember which, I think it was Rackspace's head of sustainability said something towards the effect of, if it's not green, it's not going to be economically viable, right? And I think what we're proving out is that actually being green is it's savvy business. It's like, if you don't have any cooling costs as a data center, then you just create a more profitable business, right? So I think a lot of the time people see green as a trade-off. I have to be green, I have to make some compromise. And I think when environmental and sustainability solutions are really good, you can have your cake and eat it. You know, you can provision us in the Civo platform, you can be green, and it's also really, really good value. So I think often the respecting the resources you use, using resources efficiently, is just good business. You know, it just makes sense. So even if you don't really care about the environment, or if you don't really care about sustainability, you'd still use it just because it's just better business. It's just more sustainable. And then from a kind of a resiliency point of view, it's just better compute. You know, we're not going to go offline when the grid goes offline. We're not going to, you know, it is just better business. And I think we're going back to your point. I do love this. It's so cool what Civo have done, and we're so happy to be partnered with you because it is this beautiful kind of blend of software and hardware that has taken a hell of a lot of time to get to, but we're finally there, right? And it's like all great solutions, it's just super simple. I think that's the key to this, really, just making it really easy. Yeah.
Awesome. So yeah, thanks so much for everyone tuning in, and thank you, Mark, for sharing your insights on definitely deep green, in general insights on where you think data centers are growing and which areas can be taken into consideration when we talk about or think about sustainability. Like you said, water is a whole new game. There are different levels at which you can innovate and think. So I think it should be grilling in the minds of all the folks, like what else can be done, or how we can take the existing solutions which are being developed and take it to the next level at their end as well. Like it's now happening
Yeah.
in UK, how things can be expanded globally for
Yeah.
this particular thing. And I think those areas are really cool, and so glad to have you as partners in other side of professional world as well.
Thank you for
So
having
yeah,
me. Yeah. And if anyone wants to
any
reach out, more questions, find me on LinkedIn, find Civo, go to the Civo site. Yeah. Happy to answer questions.
yeah, any final closing thoughts, Divya or Mark? Anything you would like to add?
No, I think all good. Thank you for having me. It's always great to. We're very passionate about this, and you Civo are as well. So we're just happy to kind of, yeah, we're just happy to talk about it. It's no hardship to talk about it. We love talking about it.
Awesome.
Thank you
Thank you
for
all.
coming on, by the way, and thank you, Sayam, for this. You know, um, bringing on Mark as well. And having this partnership with him, because I definitely learned a lot today, and this was like a really enlightening session for me personally. So thank you for this.
Brilliant.
Amazing. Thank you all. We'll see you tomorrow, 8:30 a.m. PST, with another sustainability session. Tomorrow we'll be talking about smart scalers, another very interesting, cool concept by Avesha. So stay tuned and come back tomorrow live. Thank you all. Bye. Have a nice day.
Appreciate